Alright, so the previous video talked about the frame of reference here, where y I've defined as this way, that's positive y, and this is positive x. They are directions. I want to point something out. This x initial or initial position and this x final, xf final position, these are initial, these are just places. This is where you start, this is where you finish. See how it doesn't have the hat on it? Like this, that means these aren't directions. They're just a symbol that means position. All right, so basically what happened is in the y direction, I traveled negative y, because that's positive, this way, and then I traveled, or 7 meters, negative y, then positive 3 in the x direction, then positive y, positive x, negative y, negative x, positive y. And the whole goal is going to be to find out displacement, not distance. Let me talk about the difference real quick. Distance is how much you traveled. Like how much total you've traveled. Displacement, I'm going to write through this x, but that says xi, is, here, I'm going to, whoops, this is displacement, is, man, sorry, the announcements. Anyway, so displacement is how much space there is between where you started and where you finished. And the biggest difference is that distance is a scalar and displacement is a vector. Think about that. Think about why that might be for just a second. Pause if you have to. All right, I'm going to start with displacement. See, where you start is a place. Where you finish is a place. If you're going from one place to another place, there is a direction to get there. Distance is just like this total. It's like 7 plus 3, that's 10. Plus 1, that's 11, another 11, 22, plus 8, 30, 32, 36, like 46 would be like the total distance. It's just everywhere. Think of it this way. If you were going to fly from here to New York and you bought like, a good ticket, it was like, straight through. You just fly from Houston to New York. That's a direction. It's like northeast. But say that you waited at the last minute and you didn't want to pay a lot, so you bought a cheap ticket, so you had to go through like every airport. Well, point to those airports at the same time. You can't. It's just in all directions. You would travel a really great distance, but Houston and New York would still be the same amount of space and have the same amount of space between them. So it's kind of like here would be Houston, here would be New York. That's got a direction. But this maybe is all the crazy airports you had to go to. That's the distance. We don't really deal with distance that much because it's not very specific. In physics, we use displacement. And displacement can have a lot of symbols. You can really call it what you want. Often you'll see it as an S with an arrow because it's a vector. Sometimes you'll see it just like it's like equation or formula, or not formula, just change in X written out. Sometimes change in Y if it's up and down. I've seen it as R, which is fine. Any of those are okay. But I liked what second and third period used actually. For displacement, you can use, as long as you define it, smiley face with a vector equals displacement. I am totally fine if you ever want to do this. Make up your own symbols and use that. But just remember, displacement, vector means change in position.